Welcome to The Case of the Ejected Electrons, a story about how an accidental spark ignited a quantum revolution. In 1887, Heinrich Hertz was studying electromagnetic waves. He found that shining UV light on his apparatus made the spark jump farther. This phenomenon, where UV light ejects electrons from metal, is known today as the photoelectric effect. Hertz's assistant, Philipp Leonard, investigated further. The prevailing wave theory of light predicted that brighter light, meaning more energy, should result in electrons being ejected with greater speed and kinetic energy. Leonard's tool for measuring electron speed was ingenious. He used a, quote, stopping voltage to repel the electrons. The higher the voltage needed to stop the current, the higher the maximum kinetic energy of the electrons. The results were a plot twist. When Leonard increased the light intensity, the stopping voltage did not change. Brighter light ejected more electrons, but not faster ones. The core prediction of wave theory was wrong. Leonard proposed the quote, only triggers electrons, like a match lighting a cannon. The energy of the electron, or the cannonball speed, came from within the metal, or the gunpowder, not the intensity of the light. However, Leonard's trigger hypothesis quickly crumbled. New experiments showed that the frequency, or color, of the light was crucial. High-frequency light ejected electrons with more kinetic energy, and below a certain threshold frequency, no electrons were ejected at all. A few years earlier, Max Planck had made a mathematical trick, an act of despair, to explain blackbody radiation. He proposed that energy was transferred in discrete packets, or quanta, where the energy, E, was proportional to the frequency, F, as shown by E equals hf. In 1905, Albert Einstein connected Planck's mathematical trick to Leonard's failed experiments. What if light itself was not a continuous wave, but fundamentally composed of these discrete energy packets, which he called photons? The photon theory solved the case. Brighter light means more photons, like more mosquitoes, which eject more electrons, but the maximum energy remains the same. The energy of each photon is locked to its frequency, like a high-frequency bullet with high energy. Despite solving the puzzle, the scientific establishment rejected the photon theory. It challenged a century of evidence that light behaved as a wave. Even Max Planck apologized for Einstein's, quote, hypothesis of light quanta, calling it a speculation. The final antagonist was Robert Millikan, a skeptical experimental physicist. He embarked on a multi-year crusade with the explicit goal of disproving Einstein's photoelectric equation. Einstein's theory predicted a simple straight-line relationship between the stopping voltage and the light's frequency. The audacious claim was that the slope of this line, h/e, would be a universal constant for any metal. Case closed. Millikan's meticulous results were undeniable. The graph was a perfect straight line, and the slope was exactly the same for every metal. The calculated value of Planck's constant from the slope perfectly matched Planck's value. Einstein's photon model had won. The aftermath saw Einstein awarded the Nobel Prize in 1921 for his discovery of the law of the photoelectric effect. Millikan's experiment provided irrefutable proof that light was a particle, establishing the wave-particle duality and ushering in the chaotic beginning of the quantum age.